How you guys doing? Good? All right. It's always good to do TechEd. This is one of my favorite events. I look forward to this every year. See lots of new faces. That's good. Introduce myself to some new people. See lots of familiar people. You guys even sit in the same chairs year to year. I think that is your name on the back of the chair. You know. But this is cool. All of my sessions except the ISO-server exchange session will be in this room. So that's pretty comfortable, right? In other words, you don't need to leave. You can stay where you are. The chair, will gradually conform to the shape of your ass, and it's just extremely comfortable, right? Except you're not allowed to fall asleep. Can't do that. So we'll make sure that you're filled with caffeine. How many of you have had a chance to look at XP Service Pack 2 so far? Okay. For those of you who haven't, you must do this. This is not an option. You need to get familiar with this. There are quite a number of changes that have been made to the operating system in this service pack, and it will affect your deployments of the operating system. It will affect some of your internal applications. I promise you this. If you've been looking for something to come along that would help ensure a little bit longer job security, at least for the next year, this is it. All right? Now, we're going to spend the next 75 minutes together today exploring some of the security features, enhancements in XP Service Pack 2. I'm not going to talk about some of the computer management stuff. I'm a security guy, so this session will focus on the security changes. For those of you who've not seen me at events before, my name is Steve Riley. I can't even say it now, sorry. My name is Steve Riley. I'm a product manager in the security business unit at Microsoft. My job is essentially doing this kind of thing, speaking at events, telling you about some of our technology, and the new things you can do with it, updating you, and then responding to email pretty much is the other part of my job. So that's why my email address is on the slide. I want you to write to me. My job is to talk to you, feel your pain, so that I can then go back to the product groups and be a pain. And I need your help with that, right? By sending me mail. So let's get into this. What is Service Pack 2? Well, it's all of the usual stuff, of course, right? It's post-Service Pack 1, whatever we're calling them. Hot fixes, patches, updates, but with more testing. And this is a good thing, right? This is an important thing. You might say, why don't you just test these patches to begin with? Well, we do, right? But there's a philosophy behind a patch. The philosophy is that, well, if there's a vulnerability around and exploit code exists, then we want to get the patch out quickly. So we only do a minimal amount of testing. This means that in service packs, the patches have more testing. Maybe fix a few bugs that we run into. If you can delay a patch installation until the next service pack, that's the right thing to do. How do you do that? If you look at a security bulletin now, you'll see there's a section called Mitigating Factors. In the Mitigating Factors section is a list of things you can do to reduce the effects of an exploit other than patching. And this is something I encourage you to think about doing. But there's some new security technologies in the service pack also around these areas: network protection, memory protection, safer email handling, more secure browsing, improved computer maintenance, and some updated features. We'll look at some of these, not all of them. Now, I need to tell you something. We broke a promise. Okay, like this is news to you, right? You remember a long time ago, back in the days of NT4, and I think it was finally with Service Pack 4, we said, no more features in service packs. We'll never do this to you again. Remember that? Well, we broke that promise. But it's for your own good. Right? Let me ask you this. If you went to download.microsoft.com and said, show me all the XP stuff, and you saw a service pack, and then you saw something that was labeled a security feature pack, would you have downloaded and installed that thing? Maybe you would have looked at it on one or two computers, and you would have thought, yeah, this is kind of cool, but I'm not going to plan for this. It's just another thing I got to deal with. Our view is that the changes we have made in the operating system with the service pack, updated firewalls, RPC changes, the things we will be exploring today, are critical enough and necessary enough in any environment that we have put them in a service pack. Because service packs are things that customers, you guys, typically consider to be a critical thing to plan and deploy, right? So we wanted your thinking about this to be around those security updates too. This is why we intentionally broke that promise from those old NT4 days. And I think that maybe you'll be glad we did. So this is your pain, right? Attackers are flooding our environments. You turn on the computer every day and you read about an attack, or worse, there's one in your network. And it's just constant, right? It comes from everywhere. There's no way it seems to stop this flood of bad guys who only want to hurt us and harm us. Now, if we could drain the ocean, right? If we could make all of this go away, that would be one way of fixing the problem. But have we given you technologies to drain the ocean? No. What have we been giving you? We've been giving you a patch, a finger in a dike, right? And trying to make you think you can stop the ocean. So we've changed our thinking. There are some security goals here. You've seen this word, resiliency, right? We want to increase the security, resiliency, and management of the operating system and decrease your security burden. Turn the stuff on by default. And then if you need to weaken it, if you need to relax it, then you decide to do this, right? What have we always done in the past? Turned everything on, right? Are we turned on all of the features and turned off all of the security and then made you try to guess at what you had to do to be correct? And usually there were 3 or 4 different guides and none of them seemed to be identical, right? So how do you figure out which one to do? Well, now we're going to turn on all of the security stuff, most of it anyway, and you consciously need to decide to change it, to weaken it, because there's probably a business need that requires you to do that. But different philosophy, different thinking, right? We want to reduce damage of worms and viruses even if patches aren't installed. This is this notion of increasing the resiliency, right? You might not be able to install a patch right now for some reason or another. So we want the operating system to be able to still survive in that kind of an environment. Essentially, it's about this. Making the attackers work harder. Making us, you guys, your environments, too difficult to get into. Or uninteresting to an attacker, right? What do we do in the physical world to make ourselves uninteresting to an attacker, a burglar? What do you do in your house? Hide all of the expensive stuff. Security by obscurity is marginally better than no security at all. But lock your door, right? Maybe buy an alarm system. What comes in the box with the alarm system? A sticker. Right? It says protected by an alarm system. Or a sign that says protected by an alarm system. Now, if you buy one at Radio Shack, you got to go buy another brand of sticker, right? And protected by a Radio Shack alarm system. Yeah, okay, I know how to take those apart. But but it's the sticker, right? You're a burglar, walking down the street. You see a house, looks kind of cool. Has a sticker, protected by an alarm system. What are you going to do? Are you going to break in? Or are you going to move on? You're probably going to move on, right? So what does this mean? If you buy an alarm system and put the sticker on your window, you are directly, negatively affecting the security posture of your neighbors. Not necessarily a bad thing, but it's true, right? But it's the sticker. Wouldn't it be nice if we could just put a picture of a firewall in front of our networks? Unfortunately, it doesn't work that way in the electronic world, right? But if we have other kinds of barriers up, that people are sniffing the computers and trying to do things, and it just gets rebuffed and rebuffed and rebuffed, maybe, just maybe, they'll move on. Now, you hear about this in a lot of security conversations, right? This idea of defense in depth. Where have we as security people always done a good job? Perimeter, right? The network, the orange thing. And usually applications, right? Lots of things in applications and data. What have we not done a good job? Hint, yeah, it's the purple one, right? But the green one too, right? What kinds of technologies exists in most computers, right, at the computer level, at the host level, to protect the host? Not much, unfortunately. So this is the principal protection scenario of the service pack, is beginning to make this evolution from edge to host security. If you think about it for a minute, how many perimeters do you have in your network? The answer to the question is, how many devices do you have connected to your network, right? Every device is an extension of the perimeter. Is this a corporate domain-joined laptop, sir? Yes. OK. And now it's sitting away from the confines of your corporate network in an area that could potentially be maybe hostile. Yes. ComNet at TechEd. In a security session, right? OK? So there's some danger there, right? Right. This gentleman's network perimeter has just been extended to room 6B at the conference center in San Diego, California, right? We will examine points 2 through 5 there as we look at the kinds of scenarios that we are solving with the Service Pack in XP Service Pack 2. Now, again, for those of you who've not ever been in sessions with me before, I'm a fairly informal guy. That's probably obvious to you. If we're talking about something and you have a question, would you just put your hand up and we'll just answer the question right there? I like to do this because the context of the conversation is right there with the question, and we can just get it answered right away. If we save it until the end, I promise you, I will run out of time, right? Now, I'll be done on time, but I don't save time for Q&A, so I want to get the questions right away while they're on your mind. That's just the thing I like to do. So the first scenario, blocking attacks. Well, what's the bad stuff? The bad stuff is computers can do a lot, right? But often they're used for just a few things. My father has a PC running Windows 98. Been trying to get him to upgrade to Windows XP, but he lives in Ohio, so it's kind of a difficult thing for me to do. I don't go there very often. But he's running Windows 98. And Windows 98 runs a lot of stuff, right? Listens on lots of ports. But he only uses it for email and surfing the web. You're familiar with Windows 98, right? All of you guys know this operating system? It's not an operating system. It's a game. The game's keeping it alive. Nintendo. Anyway, he only does a few things with this computer, right? But yet, there's lots of ways to attack that box. Because it'll take just about any packet that arrives on the network interface. People don't know how to limit what comes into the computer. If you're only using the computer for web browsing and email, you should be able to block anything that is not web browser or email traffic from getting into the machine. Existing host-based firewalls, there's a lot of products out there that can do that. They're difficult to configure. They confuse people. They ask you lots of questions. Do you want to let IE talk to the internet? Yes. Do you want to let Outlook Express talk to the internet? Yes. Do you want to let AOL Instant Messenger talk to the internet? Yes. Do you want to let Notepad.exe talk to the internet? Yes. No. What does that mean if Norton Firewall says Windows or Notepad wants to talk to the internet? What have you got? It's not your computer anymore. This man reads the 10 immutable laws. I love you. Now, you have QAZ. You have a Trojan called QAZ if Notepad is trying to talk to the internet. So we have, there's been a firewall in Windows XP. Surprise! Did you know this? The thing is, it was really hard to find, right? You couldn't find the thing. We've made a lot of changes to the firewall. First of all, we changed the name. Change the name, you change the condition, right? It's now called the Windows Firewall, not Internet Connection Firewall. Here is the firewall's basic behavior. Any outbound TCP that leaves your computer, the firewall will allow the reply to come in so long as the source address is the same as the destination address of the outbound packet. If it's outbound UDP, we'll allow the traffic to come in from any source address but we close the port if there's 90 seconds of inactivity in any time during this conversation. If it's outbound broadcast or multicast, we will open the firewall for 3 seconds to permit a response from any address on the same subnet only. So this is the outbound behavior. I'll get you in just a second. We don't raise dialogues for software that wants to initiate outbound connections. Our user testing demonstrated that that was too confusing to the majority of people. So we don't have that feature in there. Hang on. First question back here? Yeah. Somebody raise their hand. Yeah.
Are those default timeouts changeable?
Is the default for UDP?
The 90 and the 3?
No. The default timeouts were changeable? That was the question. The answer is no. Yes?
Could you elaborate on the third item?
If you want to join a broadcast or if you want to join a multicast group, right, or if your computer is going to send out broadcast traffic, then the firewall will allow the response to that. But it's only going to open itself for 3 seconds to allow a response. DHCP is an example. Is you send out a DHCP broadcast for your initial question. I forget whatever word they used to call it. And then the answer is actually a broadcast answer. Now, you can open the firewall for inbound requests. How does it behave in that manner? If you open the firewall for an inbound request from an application, and we'll get into more detail on this in a minute, the application must be on the exception list. So you're granting an application permission to open a port. If you want to open just a static port and just leave the thing open, that's what unsolicited first services means, then you open the static port. I'll show you the UI for how to do that. If you want to allow inbound communications to an RPC interface in the computer, then you must configure the firewall to permit RPC. This is not the same as opening it for port 135, right? We make a different exception for RPC, and I'll tell you how we do that too. So let's just look at some of this now. It's in the control panel. It used to not be there. That's where we've now placed it. The Security Center is a UI that shows you the firewall status, AV status, and Windows Update status. Are you configured to automatically download updates? Or you can just go directly to the firewall by clicking on the little world with the brick. And this is what it looks like. You can see that I took this screenshot from my picture. I've got the firewall on, and right now I'm allowing exceptions. And we'll explore what exceptions are. So, on by default. Because it was impossible to discover previously, how did you get there? Do you remember how to do it? Start, network settings, click on an interface, TCP or something. See that? Too many clicks? So we're just going to turn the thing on by default now. And there's an API. I don't talk about that here, but there's a lot of documentation on how you can configure the firewall using group policy and command lines. We'll look at the group policy interface in a bit. There was a flaw in the original ICF. It was one of the last things to start. So even if you had a fairly restrictive ICF policy, there was a brief period of time after the TCP stack started, but before the firewall started, that the computer would essentially allow anything in and out. So we've changed this now. If there exists a firewall policy of any kind, then we start the firewall at the very beginning, so that that slight window of opening doesn't exist, right? When the TCP stack starts, the firewall policy will already be applied. And then that will stay in effect until after the IP stack is shut down. Now, notice what it says there. This new policy that is applied at boot time only permits DNS, DHCP, and NetLogon. So the computer can get its address, update the DNS server with its new address, and log on to the network, right? And then after that has completed, the policy that might exist for the firewall will get applied. What's that? No wins. No. Wins is handled through NetLogon. There are now global and per interface configurations. You can apply most of the configuration elements globally. You set these, and it applies to every interface in the computer. Then you can alter the configuration per interface. This is mainly for opening static ports. Let's take a look at that, at what that might look like. on the Advanced tab of the Windows Firewall UI, I'll get you just a second, there's, you can see at the top there, the network connection settings, and it lists all of the interfaces in the computer. When you click on the settings button, you can then either enable one of the existing or add a new service. So this will allow you to statically open a port for a service on one interface only, which is typically what you would do, right? Let's say you have a Windows XP computer that is actually running the personal web server that comes with the operating system. You're going to need to open that for port 80, but you might not need that on all interfaces, just the one that's facing the internet or whatever. This is what that's for. In the back, there was a question. Yes, sir.
Yeah, the boot time policy for the Windows firewall.
Yes.
You said it allows DHCP through. Is the 3-second time limit still in place there at the time, or does it widen that window for the initial boot DHCP request?
I haven't measured that, but so the question was, during that initial policy of where at boot time it's only DNS, DHCP, and net logon. Remember, DHCP is broadcast, right? And we have a 3-second limit for broadcast traffic. So the question was, during the initial boot time, is that 3-second broadcast still in effect? I don't know the answer to that, but my guess is probably not, because sometimes DHCP answers take longer than 3 seconds to arrive. But I haven't tested it. That's a good question. Now, let's talk about this exceptions list just a little bit. Historically, how do you... Oh, yeah.
Is there anything in place to stop malicious code from making changes to the firewall?
We're going to get right to there. The question is, how do we stop malicious code from making firewall changes? We will be exploring how you change the firewall in the next several slides, and that will answer your question. How do you normally let an application talk over a firewall? What do? Well, you grit your teeth, you get on the phone, you call the firewall guy, you beg and you plead, and the answer is always what? No! Right? It's amazing how these firewall guys seem to forget that they're paid by a business unit. Right? And quite often, the business makes money by opening ports to let traffic flow. Well, but this is a technical session. I'm sorry. I won't go there any farther. But there's an interesting thing that we're doing with the firewall. I kind of like this idea. If an application wants to be able to listen as a service on Windows XP, you don't open a static port for that, although the capability to do that is still there. You register the application. Then when the application starts, the firewall will open the port, but only so long as that application is running. If the application is then shut down, the firewall will close the port. Nice thing about this is the application can run in a lower user context. The application can run as a network service, for example. But in order to register an application, you must be a local administrator. And that makes sense, right? We don't want a normal user of the computer to be able to start a listening service. So you must be a local administrator to register the app. But the application itself can run in a lower security context. Yes, Byron?
Does it open whatever port the app asks for?
It will open whatever port the application asks for it, yes. Here's how the firewall does it. Look at the second bullet there. We look at the TCP or UDP bind. The firewall, when the firewall senses a bind, it checks the list. Is the application on the allowed list? If the application is not on the list, then the Windows firewall actually prompted the user, but only if the current user is logged on as a local admin. And then you can also configure it manually if you want. Yeah.
Now, if I'm an administrator, I register an application. What if something spoofs that application?
What if something spoofs the application? Tell me, what do you have in mind?
Is it registered? What if I rename another executable to look like that?
No, it doesn't use executable names. It uses a hash of the file.
So I'd have to make it the same hash.
Yeah, and good luck. Right? Yeah, just like software restriction policies, it uses a hash. So how do you add a program or a port? On the Exceptions tab, click the Add Programs button, and it will go through and scan your computer. And actually, it just looks for stuff on the Start menu, right? Or you can hit the Browse button if you wanted to find something that wasn't on the Start menu. Hang on just a second. Or you can go the old way. You can click on Add a Port and get the interface now where you can open a static port that stays open all of the time. Yeah, question?
Yeah, if you have a port, for
Uh-huh.
Can you specify the source address? So you can say, in other words, only this corporate IT server can connect.
Okay. See that little button there that says change scope? Question was, can you specify a source address? You're getting ahead of me. I love this. This is cool. You can disallow the exceptions. Let me finish this one, I'll get you. There might be a situation where you do not want these things on this list to be allowed, right? And the example would be when you have your computer connected to a hostile network, say the hotel LAN at a computer security conference, right? You don't want to allow any exceptions here. So when you turn this on, it behaves like the old Windows firewall did. It doesn't allow anything inbound, period, at all. Now, you get a question over here. Probably. Question was, if you upgrade the app, do you have to manually re-register? That's most likely true, because it will have a new hash. But remember, you're going to be using group policy most of the time to hand these things down, right? So you won't need to do that on every computer. You just do it once and then hand out a new GPO. Now, here, who asked the source port restriction? You did. This is what that is, local subnet restriction. You can restrict that port opening to a range of source IP addresses. Now, there's a couple things that we'll do automatically. If you enable file and printer sharing on the exceptions tab, then that means it opens 137.38.39.445 for local subnet only. If you enable UPnP, it opens 1928.69 for local subnet only. There's APIs that will allow you to add additional things there if you want. So this is what it looks like. Both the application and port tabs have a change scope button. When you click that, the dialog says, do you want to allow this to come in from any computer, from computers that are only on my subnet, I'll get you just a second, or a custom list of subnets. Now, these screenshots are from release candidate 1. Prior builds didn't have that third thing. Right? So if you looked at an older one, you might not have seen that. You can see that now. Most corporate networks have more than one subnet, right? So that we needed to make sure we handle that. There's a question over here. Yeah.
To rewind to adding an application to the list, you said just like software restriction policies, can you be as granular with adding an application there as you can with software restriction policies, like adding based on certificate or system path?
Right. So the question is, does it look a lot like SRP, meaning can you use not only just a hash but a certificate or a path name? No. This is only an EXE. And the thing is, you don't have to register DLLs. This is good, right? The firewall will know if an EXE calls a DLL and the DLL actually does the port opening. That's OK. You only need to register the parent EXE. Question over here. Yes? You don't need UDP 445. What's that? Now, SMB over TCP is 445 TCP. It'll just fail, yeah. I suppose you could add UDP 445, but this is what the default is. I just took these screenshots from my PC and haven't changed the defaults, so that's what it looks like. What's that? What? 445? Oh, no. The top one is if you edit a program. The bottom one is if you edit a service, static port openings. That edit a service is the file and print sharing definition that's built into the firewall. You can do everything that you see in the UI at the command line too. Now, there's the netshwf context will allow you to control everything at the firewall. You can do most things with group policy. We'll look at that in a minute. There are a few things you can't do with group policy, but you can do it with the command line. So this is useful for scripting, for example.
Does the user still get prompted for, like if I have a batch file,
Yep.
the user would still get prompted if we make changes there?
I don't understand. Does a batch file user gets prompted?
Well, like if an application is wanting to open up a port, the user gets prompted. If I have a batch file I'm running, making changes through netsh.
Right. Oh, no. There are no user prompts when you do stuff with the command line. It just plumbs the policy into the firewall immediately. Group policy support. Control the things there that you see on the list. Note that it's for IPv4 only. If you're doing IPv6, probably nobody here would be doing that, I suspect. The GPO settings are still only for on and off. If you want to do automated settings for IPv6, you'll need to do that using the command line only. This is what the UI looks like. It's a local computer. It's a computer policy. right? And this is a screenshot from my PC, so it's a local policy. It's not the one that Microsoft's corp domain is putting down. But you would configure that in the computer policy, not in the user policy. Now we have multiple profiles in the firewall. This is location-based. This only works if the machine is joined to a domain. If the computer is not domain joined, then this feature does not enable itself. But if you are domain joined and the computer logged into the domain, then the computer will use the firewall policy that is configured for domain participation, right? If the computer was not successfully able to log into the domain, the firewall assumes that the machine is remote and will apply a remote configuration. So in your GPO, you would define two configs. Maybe a more relaxed configuration for when the computer is on the CorpNet so that it can participate in things like file and print sharing, SMS, whatever you want to do, right? Software updates, these kinds of things. Then you'd have a separate policy for when the computer is remote that would have no restrictions, file and print sharing turned off, for example, and then the computer knows which one to pick when it boots up. Yeah. Okay, so that's a good question. So we're sitting in our CorpNet, logged into the domain, pick up the computer and go home. If you power down and then go home and plug it in and power up, it'll know that it's not logged onto the domain, so it'll apply the more restrictive setting. If you hibernate, leave, and then attach the computer, it doesn't really know you've left, right? So it stays in the corp setting. Now, so by GPO, you want to disable hibernation on the machine, right? Yeah, that's interesting. I've never had anybody ask that question before. And there ought to be a way, that we could just periodically poll, right? And if the computer is not on the domain anymore, gee, I'm going to go talk to somebody about that. What? Yeah. That's good. Thank you. I like that. We'll take two more questions and need to move on. Yeah. Well, this is the same thing we're talking about here. But this is machine. This is not user. We don't care about the user here. We're just checking. This is how the thing does its location awareness, is if it was able to do a computer the log onto the domain or not, right? And that was the question we were getting back here. So I love that. Thank you. Yeah?
What about like a VPN client and a split tunnel configuration? Would the corporate filtering on the VPN adapter?
VPN client in a split tunnel configuration, you, sir, are begging to be attacked. You don't actually run with split tunneling, do you? Okay, I'm just asking, he says. There's no built-in VPN awareness to this thing, right? So what you would do in this case, the computer is disconnected from the CorpNet, so when it boots up, it's going to apply the more restrictive policy, but that's only applied to the underlying LAN or dial-up connection, right? When you make a VPN connection then into the CorpNet, there is no firewall setting on the VPN connection. So that means on the underlying LAN connection, the firewall will need to permit the VPN protocols, and we will permit IPsec and PPTP here. Those pass through the firewall just fine. RPC support. If you needed to allow a machine to make an RPC connection into a computer running the old internet connection firewall in the original XP, there was no way to do this, because RPC programs run on dynamic ports, right? Now the firewall understands this service host.exe. This is the RPC, basically, wrapper, right? When an application registers itself with service host, if you enable RPC support in the firewall, then when the application starts, the firewall will allow that application's dynamic port to be accessed. There is also, this is new, an unattended setup. So you can customize the firewall's configuration. If you have a build of Windows XP that you make your computers from on your LAN somewhere, right, that you've slipstreamed in service packs and hotfixes into, you can slipstream in a custom firewall configuration if you want. You guys are all doing that, right? You're not actually building computers from the CD-ROMs anymore? I need you all to do me a favor. I need you to, who had the question? I'll get you in just a second. I need you to go into your computer rooms, look behind every server, look underneath every air conditioning unit, in the filing cabinets, anywhere you can find. I want you to find your original RTM CDs of Windows 2000, Windows XP, and SQL Server 2000, break them in half, and throw them away. If you're still building the operating systems from the original CDs, and you have the LAN cable attached, you're just inviting disaster. Don't forget to do this to your VMs, too. Yes? The bleach blonde shorts wearing kid speaks from experience here. You had a question? Slipstream the server. Okay, this firewall that I'm exploring here is Windows XP Service Pack 2. It will most likely be present in Server 2003 Service Pack 1. You know, I could stand up here and perform chronological proctology for you, but that's not a pleasant experience for any of us. So I don't know when the Service Pack is going to come out. Sorry. Yeah. Log reporting, the reporting mechanism looks the same as it did in the old version. There's no reporting. You're asking for, tell the central log when this firewall sees a bad packet, right?
I'm asking for some information that'll tell me what the hell's going on, whether it's the corporate firewall or the PC firewall.
Oh, well, we have logging, right? But it just logs to the local hard drive.
And then what are the tools that I use to report that?
Okay, so I didn't talk about it here because it hasn't been changed. But there is a logging capability in the Windows firewall, and you can indicate whether to log successful connections or dropped packets. Now, we don't log successful packets. That would be a useful hard drive filling exercise. But you can turn on either or both of these, and it will log to c:/p firewall.log, I think it is. So you could maybe, and that's all we do, right? And it's just a comma delimited file. So if you had some process running on the machine that would periodically harvest that and send it to some centralized place, you could. But that's the extent of the reporting in the current version. Yeah, last question. We need to move on. Will any of this functionality be operational in Windows PE? I don't know the answer to that. I don't really pay attention to that product. I'm sorry. If you need an answer to that, would you drop me an email? And I'll get you an answer. Okay, so this is the up next scenario, right? Are you sick of? Have you ever seen this thing? Right? Are you sick of pop-up ads? Here, click on this pop-up ad. Okay. Yeah, and get some spyware. So it's pretty easy to trick people into installing stuff, right? Visit a website in Germany, get some bad stuff. I don't know why this is. I spend a lot of time looking at the dark corners of the internet, right? I feel like I need to know this. And it seems lately that a lot of the bad stuff happens to be coming out of servers in Germany. I don't have an answer why. It's just an observation I've made. I'll get your question in a second. And, you know, people confuse people by doing some weird window trickery. So we have done some change. We've made some changes that block a lot of this window trickery from happening, and we're going to explore that. Yes, sir.
There was a question about window trickery.
Oh.
It was a pop-up ad that looked like it was two separate windows.
A pop-up ad that looked like two separate windows.
And if you click on the upper right-hand corner.
Click on the upper right-hand corner
of the upper window.
It
wasn't a separate window. And it kicked off.
See, just another example of something that looked like two windows, but you click on one of them and nastiness ensued, right? Well, these are the kinds of things now that we're going to be trying to take care of in the next series of features that I'd like to tell you about. The Service Pack will apply window restrictions to the operating system. So what does this mean? Well, scripts can't position or resize windows with the title bar and the status bar off screen. One of the beauties of a window is you know it's a window. And how do you know it's a window? There are visual elements that are telling you this. Status bar, title bar, menu bar, icons, borders, right? All of these things. Let's say I went to a website somewhere, and there was a script that got kicked off that measured the dimensions of my screen, 1280 by 1024, and it opens up a window that's 1290 by 1054 and centers it. Now, does it look like I'm in a window anymore? Let's say, furthermore, that this, quote, window had some icons, and these icons were labeled, say, my computer, my network places, recycle bin. And then let's say that the script opened up now a thing that looked like a window, and it said, your connection to the network has been lost. Please re-enter your ID and password. Have you seen this one? So we're trying to, and I think we've probably done I think we've succeeded here with the design changes we've made, eliminate these windows that attempt to spoof desktop objects. You can always see the security zone now, and you can't overlay the address bar anymore. The address bar must remain visible so that you know you are looking at a URL. Different things, can't move windows off screen or open windows in kiosk mode now. And any pop-up windows that rely on these things will simply be truncated. We'll just cut the window off. So if you're doing this in your code now, you're going to need to change it. Maybe you're getting this hint now. If some of you in this room are developers, there are some changes you will need to make. These are changes for the user's own good. They are very heavily documented in some URLs that I will give you at the end of the presentation. There is work for you to do. Now, as a result of adding some window restrictions, we have implemented a pop-up blocker in Internet Explorer. Any background or script window that gets opened by those commands you see there will essentially be blocked if you've turned on the pop-up blocker. Doesn't affect windows essentially that are user-generated. If you as a developer want to take advantage of this, there's a new API for you. Now, why are we adding a pop-up blocker into Internet Explorer? Say it with me, friends. Are you ready? Pop-ups suck. Don't they? Hang on just a second. I might answer your question here. Any window that tries to open something outside the viewable area will simply get repositioned into the viewable area. If it tries to open larger, it will get shrunk down. But if you're in trusted sites or intranet zones, then we don't apply those restrictions to the pop-up blocker. Your question?
Yes, there are some shockwave and client-side OCX that show windows that are not really Internet Explorer windows.
Right.
It doesn't detect them as pop-up.
Yep. ActiveX controls on a website. We don't apply this to that. Right? It's just windows that are opened by that. This is 99% of them. Right. Here are some pop-up controls that you get. The question was, what about things like Flash animations and things like that? That's why I backed up to the slide. Flash is run by an OCX, so we won't stop the Flash windows. So uninstall Flash. Actually, you know what? I've done this. Really, I have. I've gotten rid of it. It's distracting more than anything else. But also, it's the safety versus dancing pigs scenario, right? It doesn't matter. Users will open up a window promising dancing pigs every time. So here are the things that you can do with the pop-up blocker. Let's just take a look at it. It's very simple. Turn on pop-up blocker. That's all you do. It's on the privacy tab. If you want to allow some certain exceptions, you can click the options button and add URLs there if you would like. And so the pop-up blocker will not be applied even to these particular URLs that might be in the internet zone. Now, it was a question somewhere. I heard somebody say something. Yeah. Is that list manageable by group policy? Absolutely, sir. You remember this? Before Service Pack 2? If you turned on ActiveX, prompt me before downloading, it would tell you this. Did this really give you anything useful? Did you know how to make a decision based on this box? Well, then you might as well have got that one. Right? They say the same thing. Oh, yeah, but the Swedish man says that's understandable. Yeah, okay. Thank you. I've never gotten applause for an audience member before. That's cool. We have this thing called untrusted publishers mitigation. That's a long, long phrase for what are we doing? Well, now you get that. See the thing in the red? It's not very visible now. We're going to change that color and make it more noticeable in the next build. But it says there, to help protect your security, i.e. stop this site from installing software on your computer. If you want to do it, then you click there and you get this dialog box. Do you want to always install? Or here's a new thing, never install. Right? Remember the previous one? There's only one choice. Trust this publisher. Well, now we're avoiding a social engineering attack here. Let's go back. Look at this thing. Okay? Always trust content from Apple Computer. Let's say you went to a website somewhere that was filled with 99 controls. And you have Prompt Me installed. And the 99th control is the one that's delivering the bad code. So you go to the page opens up. Do you want to install? No. Install? No. Install? No. Install? No. Install? No. Install? No. Ah, hell, yes! Just to get rid of the dialogues, right? And the others will then load, and the bad code gets on your machine. This, you want to have a button on there that says, never trust Apple Computer, right? See, I work for Microsoft. I'm allowed to say these things. Well, that's what this button is. The never install software from whoever, right? To avoid that social engineering attack. We have done a lot of evaluation of crashes of Internet Explorer. There's a lot to evaluate. No, and we have found that most of the crashes are not the result of bad code in IE. Shock, amazement. It's add-ons. What's an add-on? Are you using the Google toolbar? You know the best way to search Microsoft.com? So, see? Right? So we found that a lot of add-ons are the things that are really destroying, that cause instability in Internet Explorer. So we have now given you an ability to do add-on management, right? There's a UI, I'll show you in a second, that lists all of the add-ons, either the ones that are currently loaded or the ones that have ever, once in their life, been loaded. And you can control whether the thing should get loaded or not. Now, we don't have an uninstall. I mean, how can IE figure out how to uninstall that, right? Hopefully, there's one in add remove programs that's not like Gators that just pretends it uninstalled. But we can at least disable the thing from loading, right? This is what it looks like. There's a screenshot from my computer. Add-ons currently loaded, and then you can see that I've disabled the ones that I never use. No. Then you can just pick and choose, right? But there's another cool thing about the add-ons. It's not just that. It's this idea of crash detection, right? When an add-on crashes, Internet Explorer will get a list of the DLLs that are currently loaded in memory and then see where the instruction pointer register is. It will then be able to see which DLL crashed, right? Because the instruction pointer is pointing to the memory address of the next instruction the CPU executes. We can tell which DLL was the one that crashed and then raise the dialog and say, do you want to disable this particular add-on or not? Kind of a nice little trick. There's also an administrative control. Somebody in the back asked about GPOs. Here's yet another thing. Another thing you can do with GPOs is you can control whether users have normal control over add-ons, or you can have a loose or strong restriction. The loose restriction is the deny list, right? You specify the bad things that you know you don't want people to do, and then you let them otherwise install add-ons. Or you can be more restricted, the allow list, where you only list the things that users are permitted to use and block any other kind of add-on from being installed. Yes, sir?
Back a slide?
Yep.
Really cool add-on thing.
Don't you love PowerPoint animations?
Yeah.
That's just great.
Are we going to capture that with Watson?
Capture it with Watson.
Yeah. Is there any way that we can start reporting that back?
I don't know the answer to that question. That sounds like a pretty useful thing. Pop me an email, and I'll get an answer for you. That would be good. Right now, I don't know of any central reporting for this. Okay, yes?
When you're blocking add-ons, does the user get the message, or is it just...
No, that management dialog comes up. Oh, you're saying when you do this administratively? No, there's no. This just gets applied to the computer. No. Okay, how about this one? Would you like to stop mail orders? I need to move on. We can talk later. Would this be a good idea? Right? You know, people keep opening attachments. Right? I'm beginning to lose my sympathy. I mean, come on. What is this? Right? I love you. All caps, no spaces. Who writes like this? So there's a thing called the Attachment Execution Service. Outlook Express and Windows Messenger will use this. It's an API that's there that will give you a consistent user experience across multiple applications for handling attachments. The next version of Outlook will use this too. So basically, it's new dialogues, right? If you turn on, do not allow attachments to be saved or opened that could potentially be a virus in Outlook Express, and you get a piece of mail that has an attachment, it turns on the yellow thing there, and it says it has removed access to the unsafe attachment. If you have that turned off, then you get this dialog when you try to open an attachment that came in mail. Again, this is a lot of the dialogues have been rewritten, right? To be less confusing, to give you more information from which to make a decision. There is also a plain text mode. You could just say, hey, you know what? I don't want to deal with HTML mail. I just want to read all text, all mail in plain text. I just, period, right? By the way, would you all please do me a favor? And in Outlook, not Outlook Express, but in your Outlook, would you please change your profile and go to rich text? Stop writing HTML mail, which is the default, right? Go to rich text. First of all, it's smaller. It gives you more formatting options for fonts and colors and cool stuff like that, right? And it's not a delivery of malicious code. My personal opinion is that the invention of HTML mail was a bad mistake. Right? It wasn't a Microsoft invention. I just think that HTML mail is a bad idea. Executable code has no business in email. So if you could do me a favor, please, and change your profile to go to rich text, that would make me a happy man. You know, I have some control over the other product groups, but, you know, I'm just one guy. So maybe better, email me. I'll collect, hey, you know what? If I could get a mail from 1,000 angry Americans that said, shut off HTML mail, and I could bulk this up and send it to somebody who cares, this would be good, right? But I need to hear it from you. This is why I ask you to do these favors for me at events, right? So when you turn on plain text mode, that's it. Read all messages in plain text. This is what you get, right? You can see there the HTML now appears as an attachment that just takes the text out and displays it. If you then decide you want to look at this particular message in HTML mail, you could click on the View menu, and you can see there's a new choice. View as HTML, or message in HTML. Another thing is not directly related to malicious code, but since I'm talking about Outlook Express, I decided to put the slide in here. This idea of no external HTML mail content. Y'all know what a web bug is? Little 1-pixel GIF, white foreground, white background. It's not actually delivered to your computer, but it's an href in the HTML mail. So when your computer processes it, it goes out to the server and grabs the 1-pixel GIF and displays it. Well, what does MS-HTML do when it goes out and resolves a URL? It sends your IP address, right? So this means the spammer knows you got the mail just by opening it. So we will now, if you click that button or that checkbox that says block images and other external content in HTML mail, you get that, right? In other words, this little 1K only opportunity that I got from United I couldn't read, which maybe is not a bad thing. You have to then click see the line there? It's in gray. Some pictures have been blocked. Click here to download the pictures. If you click that, then it will go out and resolve those hrefs to images. A couple other things with IE. There was an interesting little thing that could happen if you got a script on your machine. It could navigate to another page that's in a less restrictive security zone. So we've we've stopped that behavior. That behavior can't happen now, right? If any link on one page tries to navigate to another page that's in a less restrictive security zone, then we'll ignore the security zone of that link and apply the restrictions in the current security zone. So this stops some interesting zone elevation attack behavior, bad code that we have seen. Not an exceptionally not a very popular thing, but it's out there, right? Something that we will be adding soon, it's not in the current build, is a global exception for information based on CD-ROMs. If you have a CD-ROM that's got that uses the browser to read the content, we saw that this was actually breaking a lot of those. So there will be a global exception for things that are read from optical drives. That will be turned off by default. You'll need to enable that. That's coming in a future build. Also, similarly related, local machine zone lockdown. If you bring up the security zones thing, you see the 4 zones. There's actually a 5th one in your computer, sometimes called My Computer Zone or Local Computer Zone. It just depends on the URL or the documentation that you happen to be reading. This is it runs all local HTML pages on the computer. So if you have a file, .html, on your hard drive, that file will be executed in the local machine zone security area. We have now made some changes to the security in the local computer zone, and those changes are these. Running scripts and the other things you can see on the list there are now disallowed in the local computer zone because we were seeing some attacks where an attacker would get malicious code onto the hard drive and then call it from a web page. And that code could run in a very high security context, right? Or a very permissive security context. So we're eliminating some of those settings. Also, we're going to look at MIME files in more detail. In addition to looking at the file name extension, the content type and disposition, as well as the prog IDs that correspond with those, actually going to do a MIME sniff. We're going to look at the actual file itself. And if it's an exe file that's trying to masquerade as text, then we will change the name of the file in the cache back to exe. This is good, because if you're blocking exes, then it will now be blocked. Finally, in previous versions of Internet Explorer, there were multiple instances of MS-HTML, one per window. With IE6, there's one instance of the rendering engine, that's what MS-HTML is, for every window that might be open on the screen. So there's a cross-domain hole that could be exploited with that. Say, for example, a script in one frame from one domain that's listening for events happening in other frames from different domains, and then the script could read something from a cache, for example. So now we've said that any access to cached objects is blocked whenever there's a navigation. All right. This is one of the more challenging ones to explain. I'm going to get a little bit technical here. I hope that's OK for you. I know this is a 300 level class, but we called it 380 because it's almost a 400. Is that OK? Can we get technical here? Will this be good? All right. Buffer overruns. You all know what a buffer overrun is. I probably don't need to explain it for you. They can be eliminated with a change of programmer behavior. We're getting our programmers in Microsoft to really understand this and start putting bounds checking in all of their memory allocations. So we're getting these things out of the code, but it takes some time, right? Plus, you might have third-party applications where you don't know whether they've got buffers that are exploitable or not. So we're going to build some stuff into the OS itself that can help prevent exploiting these things. It's called data execution prevention. Good software engineering practices say that some areas of memory are for data and some areas of memory are for executable code. Never shall the twain meet. Certain areas of memory, like the default heap, various stacks, memory pools, should only contain data. They should not contain executable code. Now, bad programmers put code in areas of memory that should be only data. What kinds of programmers am I talking about here? Interns and virus writers. Okay? It's a joke, guys. Come on. CPUs that support hardware page marking have this thing called no execute. It's an operating system feature that relies on a CPU capability that marks a page of memory as executable. This means if you now are just say you have a more advanced CPU, I'll get to that in a minute, and you call a memory, you do a memory allocation in your code, these CPUs will mark this page as data only. You need to put another flag in your memory allocation call so that the page gets marked as executable code. And oh, by the way, then, if the CPU will make sure that that area of memory that gets allocated is not in the stack or heap, right? If you try to explicitly allocate or mark a stack or heap page of memory as executable, the CPU will crash. Well, not crash, it stops the app from running. So let's explore this just a little bit. Like I said, it's a hardware thing. It requires this capability in the CPU itself. All 64-bit processors from Intel support this now, and things that are based on the K8 from AMD also support it, so Athlon, Opteron. If you are running a 64-bit application, the application is expected to function with NX enabled by default. And it will also protect these 4 areas that you see. You cannot globally disable it. And remember, when you allocate memory and you call virtual alloc, you need to add a page execute star attribute in there. Otherwise, the memory will be allocated as data only and cannot run code from it. 32-bit Windows, the behavior is slightly different depending on whether the application is 32 or is a user mode or kernel mode. If it's a user mode application, we will give you the ability to selectively enable and disable the execution protection per app. I'll show you what that looks like in a bit. If for applications that have not been given the exception, if an application tries to do this bad stuff of calling code from a data page, the application will crash. We think it's better to crash than to be infected with a worm. Now, kernel mode drivers. If a kernel mode driver attempts to run code from the stack, we will blue screen the computer. This is an intentional decision. Again, it is better to crash the box than to get infected with a worm that can then spread by itself without human interaction. What does this mean in the real world? Don't worry about it. We haven't seen any commercially available application or driver that will trigger these 2 things, right? So yeah, even ATI, Driver of Elite Club, is now finally not going to be affected by kernel mode problems, right? So essentially, this is only going to get the guys who are writing the worms. Talked about a lot of the reasons already. I'm not going to spend much time on this slide here. Anytime. Here's what the end user experience looks like. 32-bit application tries to call data from the heap, and bam, you're going to get an alert. It says Windows has closed this program. If you want to then create an exception for it, you click the exceptions button, and you can put a check mark next to it. Yes, sir.
Can you set it to, let's say that you have a user base of people who aren't particularly advanced. Can you set it so that they don't get those boxes where they click on exceptions?
Oh, OK. So the question is, I don't want to allow the user to raise an exception. This is only going to appear if the user is logged on as a local administrator. If they're ordinary users, then it will just give you the first one, and the exceptions button will not appear on the dialog. But it's going to tell the user that it closed an app. All right, wrapping up here. Yes, question? What does it say? I think it just raises a bug check. Attempted execute of no execute memory. So that will appear on the blue screen for the quarter of a second that it stays on the screen, right? There's a way to fix that, but I don't know what that is. But yeah, the blue screen will tell you. That's the error you get. Yeah, it gets right into the event log. Who said that? Yeah, I forgot about that. I don't know. I don't have blue screens anymore, so I don't really remember the behavior of these, right? Ooh. Maybe I should run now. All right, time to be painfully, brutally honest with you. RPC. This code is well over a decade old. There is no one left in Microsoft who, in one brain, completely understands everything about RPC. The collective knowledge of RPC is scattered among multiple brains. Now, let me help you understand something. How many of you in this room are actual engineers by trade? Okay. So for you guys, you understand the notion of design assumptions, correct? You're given a set of you're given an environment in which to build something. There are certain assumptions you make. You engineer your thing based on those assumptions, and you're done. RPC was engineered in environments that were assumed to be trusted, because this is the environment we had 15 years ago when RPC was envisioned, right? That computers, they're small networks of computers that are trusted machines run by trusted users. This is the environment in which the software was written. Now, how many of us live in that world today? Look around. No hands, right? We're all living in hostile worlds now. RPC, nevertheless, is still present in many places in Windows. It's an underlying architecture for a lot of things. Why am I saying all of this? I'm saying all of this because I personally, Steve Riley, expect that there will be future RPC vulnerabilities that might get discovered. Again, because of the engineering assumptions made in the development of this code, right? This is true in any engineering exercise that you might undergo. Consider the Golden Gate Bridge. Built in 1935, opened to foot traffic in 1936, automobiles in 1937. This thing is well over 1,000 meters long. 1 million cars a day pass over this bridge now, right? There was a retrospective on Discovery Channel a few years ago where they interviewed the architect and engineer of this bridge. The interviewer asked the guy, what would you do different today in 2002 that you didn't do in 1935 when you built that bridge? His answer was, not a damn thing. Now, there's a reason for that, right? How long have humans been building bridges? 4,000 years. It's a well-understood scientific discipline. We know the threats against suspension bridges and how to mitigate against those, right? But not an airplane crashing into the bridge, because it's not something that would have been envisioned by the designers in 1935, right? See the point that I'm making here? So we made a couple changes to RPC to mitigate the effects of other vulnerabilities that might get discovered, as well as the effects of malicious code that is attempting to do other kinds of RPC-based attacks. What is that? It's essentially the idea of enforcing authentication. If you turn on this registry key, restrict remote clients, this means that whenever an RPC client wants to make a connection to an RPC service, the client must authenticate first. Machine-type authentication, right? Having something like that turned on will have accomplished the thing in the green box. Any worm that tries to exploit a buffer overrun through an anonymous connection will be terminated. And all worms try to talk anonymously, right? They're not going to log in. Isn't that an interesting idea, a worm that logs in? That means you got other problems in your environment, but especially the one that might actually raise a dialogue, right? So any application that performs anonymous calls is probably going to be affected by this. Now, there is a per application exception, right? Actually, you need to turn on the registry key to make it happen. This key is off by default. I've been running with my laptop with this key on for some time now, and you know what? I haven't seen anything break. But I'm in a bit of a unique environment, right? The only software I have on my computer is our own. I don't have other kinds of third-party things. So you will need to do some testing here. And if you're running a business-critical application that doesn't know how to behave in this environment, you can write that per application exception for this. So that capability is there for you. We've also then said, well, if we're going to require authentication to talk to the RPC interface, maybe we should also require authentication to talk to the port mapper, the thing running on 135 from which you learn the port number of the RPC app. If you turn on that registry key, enable auth EP resolution, you get the same behavior. If you just want to go to port 135 to query the port mapper for the application, you now, again, will need to perform an authentication using the computer account. Okay, so what's next? I actually like a lot of what we've done here. I like everything we've done, actually. I think these are the right things to do. I believe that this is succeeding in addressing the threats and improving the engineering of Windows XP to better behave in the hostile environment that we all live in today. There are some implications. I've introduced you to these. You do need to read the white papers to learn more about it. And yeah, you know what? This is our next step in trustworthy computing. Now, let me take 2 minutes here before we wrap up, and let me give you my spin on trustworthy computing. After all, you're at a Microsoft conference in a security session. Somebody needs to say this, right? 100 years ago, when electricity just started appearing in people's houses, people were afraid. Where did electricity come from? Lightning. And lightning killed people. Now you're bringing it into my house? Are you insane? But do you today have any fear at all that you're going to die if you plug the toaster into the wall? That's because you took the warning label off. No, plugging the toaster into the wall is not going to kill you. It's reaching in with the fork to get the bread out that will. Right? We have 100 years of engineering discipline, quite often enforced by regulation, but that's a different conversation, around distributing and transmitting electricity safely to people's houses. People do not drop dead when they plug appliances in, right? Would you trust that thing with your life? Even if it weren't running Windows? How old is computer science, software engineering, as an engineering discipline? Maybe 40 years old. We, small W software industry, are infants at understanding how to write provably secure, safe code. And this is what trustworthy computing is about. It's about advancing, yeah, I'm going to use this phrase, you got to forgive me, but it's about advancing the state-of-the-art of software engineering to the point where you can start to trust the machines and the software with your very life. You're already doing that some way anyway. Have you checked into a hospital recently? Right? This is what trustworthy computing is. We think this is going to be about a 10-year effort, and it's just getting started now. But this, Windows XP Service Pack 2, is a victory for the security guys. It really is. This is your way of getting better, of making your hosts become participants in the security stance of your organization. Because that's where the information lives to make those decisions, right? You're going to see these slides all the time. So please do fill one of these out. I love reading the comments that you write on there. It's very useful for me. Too bad we're not doing paper evals. I used to always have a stack of pre-completed evals up here. You can just take one on your way out, but you got to do it yourself now. So let me know what you think. Tell me what you like, what you didn't like. And hang on, wait. These are the URLs. Okay, so this is where you can learn more. And get one of these. Go to the Security Pavilion. Get this thing. Okay. And then that's me. Do write to me. I want to hear from you. Tell me what's working and what's not working. And thanks a lot. I'll see you guys more this conference.